Conquering the Corn Earworm, a gardener's guide to identification and control. This guide will cover the complete life cycle of the corn earworm, from egg to adult moth. And then we will go over a number of effective control methods to get rid of this persistent pest. The life cycle of a persistent pest, the corn earworm scientific name, Helicoverpa zea, is an agricultural menace that undergoes a complete metamorphosis, transforming through 4 distinct stages. Egg. The journey begins with the adult moth. Often active at dusk, female moths lay tiny, white, dome-shaped eggs, typically on fresh corn silks, but also on leaves and other plant parts. A single female can lay hundreds to over 1,000 eggs in her lifetime. Larva. Within 2 to 10 days, these eggs hatch into the larval stage, the hungry caterpillars that cause all the trouble. Initially small and unassuming, they rapidly grow, reaching up to 1.5 inches in length. Their color varies widely from pale green to pink, brown, or even black, often with stripes. These larvae are voracious feeders, burrowing into corn ears, tomatoes, and other fruits, leaving behind damaged kernels and frass excrement. This is the most destructive stage. Pupa. After 2 to 4 weeks of feeding, the mature larva drops to the ground and burrows a few inches into the soil. Here, it transforms into a reddish-brown pupa, a resting stage where the metamorphosis into an adult moth occurs. Adult. The pupal stage lasts about 14 to 25 days longer in cooler conditions, after which the adult moth emerges from the soil. These moths are typically light brown to grayish-brown with a wingspan of about 1.5 inches, featuring a darker spot near the center of their forewings. They are nocturnal, feed on nectar, and are primarily focused on mating and laying the next generation of eggs, perpetuating the cycle. Corn earworm versus tobacco budworm, a close relation. You might hear references to tobacco earworms, which often refer to the tobacco budworm Heliothis. These two species are very closely related, and can be challenging to distinguish in their larval stage without close examination. Both are significant agricultural pests. While their preferred host plants differ somewhat, their destructive feeding habits and life cycles are quite similar, meaning many control strategies apply to both. Multi-pronged approach. Effective control methods. Successfully managing corn earworms often requires a combination of strategies, targeting different stages of their life cycle. 1. Spinosad, an organic-friendly insecticide. Spinosad is a naturally derived insecticide, produced by the fermentation of a soil bacterium Sucteropolis spora, Spinosa. It's highly effective against a range of chewing insects, including corn, earworms, and is approved for organic gardening. How it works. Spinosad affects the insect's nervous system when ingested or through direct contact. It causes rapid excitation of the insect nervous system, leading to paralysis and death within a few days. Application. Always follow product label instructions carefully. Typically, it's mixed with water and sprayed onto the corn silks as soon as they emerge. Silks are the primary entry point for newly hatched larvae. Repeat applications every 4 to 7 days during the silking period are often necessary to maintain protection, as new silks continuously grow and moths continue to lay eggs. 2. Gemstar. Viral biocontrol. Gemstar is a biological insecticide that harnesses the power of nature to fight pests. Its active ingredient is a naturally occurring nuclear polyhedrosis virus, NPV, specifically pathogenic to Helicoverpa species like the corn earworm and tobacco budworm. How it works. The virus must be ingested by the larvae. Once inside, it replicates within the caterpillar's body, causing it to sicken and die. Infected larvae often become sluggish and eventually liquefy, releasing billions of new virus particles that can then infect other larvae who feed on the contaminated plant material. This makes Gemstar a self-perpetuating control agent. Application. Because it relies on ingestion and takes time to work, Gemstar is most effective when applied to young, newly hatched larvae first or second instar before they cause significant damage. Early and thorough coverage is crucial. 3. Dynatrap. Trapping the adults. Targeting the adult moth stage can significantly reduce the number of eggs laid, thus lowering the larval population. Dynatrap systems offer an effective mechanical control method. How it works. Dynatraps utilize a combination of UV light, blacklight, and sometimes CO2 or other attractants to lure nocturnal insects, including corn, earworm moths. Once attracted, a powerful fan draws the insects into a retaining cage where they dehydrate and die. Purpose. By catching and killing adult moths, Dynatraps help to break the reproductive cycle, reducing overall pest pressure in your garden or field. Strategic placement away from your immediate growing area can draw moths away from your crops. 4. Trichogramma wasps. Tiny biological assassins. Introducing beneficial insects is a cornerstone of biological pest control. Trichogramma wasps are incredibly tiny parasitic wasps that are natural enemies of corn earworms. How it works. These minute wasps don't sting humans. Instead, the female trichogramma wasp lays her own eggs inside the eggs of the corn earworm moth. The developing wasp larva consumes the developing earworm embryo, effectively killing the pest before it even has a chance to hatch and begin feeding on your plants. Application. Trichogramma wasps are typically released in batches during periods of peak moth activity. Multiple releases are often recommended to ensure continuous coverage against successive generations of pest eggs. 5. Physical covers. The ultimate barrier. Sometimes the simplest solutions are the most effective. Physically excluding the adult moths from your plants is a highly reliable way to prevent egg laying. How it works. This method involves completely covering your plants with fine mesh screens or specialized agricultural netting, such as Type RT 518 row cover. These materials have openings small enough to block the moths but still allow sunlight, air, and water to reach the plants. For greenhouse operations, fine screens over vents and doorways serve a similar purpose. Benefits. Physical barriers are non-toxic, provide immediate protection, and are effective against a wide range of flying pests. They are particularly useful for protecting individual plants or smaller garden beds. Ensure the covers are secured to prevent moths from crawling underneath. By understanding the corn earworm's life cycle and employing a combination of these control methods, you can significantly reduce damage and enjoy a more bountiful harvest. Implementing an integrated pest management (IPM) approach, combining cultural practices, biological controls, and judicious use of pesticides is the most sustainable path to victory against this persistent pest.